Hi there, it's Miss B. It is Monday, April 1st. I am out today. I have a couple of doctor's appointments. I am totally fine and I will be back tomorrow. So I would like you to pause the lesson right now and do these two-step equations when you're doing them in your math notebook, and then when you're done, unpause the video. Okay, so hopefully you remembered to draw your equal sign going down, and we always get rid of the adding or subtracting first. The opposite of adding 5 is subtracting 5. Whatever you do on one side of the equal sign, you do on the other. And I'm going to draw that line here so I can do what I have so far. So 26 minus 5 is 21. These cancel each other out, and we are left with 3 times x. The opposite of multiplying by 3 is dividing by 3. These cancel out. I'm left with x, and 21 divided by 3 is 7, so x equals 7. All right, now we have m divided by 3 minus 4 equals 9. We will get rid of that 4 first, so the opposite of subtracting 4 is adding 4. 9 plus 4 is 13. Those cancel, and we are still having m divided by 3. The opposite of dividing by 3 is multiplying by 3. These cancel out, and so I have m equals 39. 13 times 3 is 39. All right, so we are starting lesson 10.1.2. What is the relationship? Distance, rate, and time. Throughout this course, you've been developing skills for writing equations to describe relationships in tables, in graphs, and in situations. Today, you will use your equation writing skills to represent the relationships between rate, time, and distance. Axel is getting his pig ready for the pig races at the county fair. During the race, 4 juvenile pigs run along a straight track, trying to be the first pig to get a cream-filled chocolate cookie. His pig, Hammy, can run at a rate of 11 feet per second. All right, important information. At this speed, how far will Hammy run in 3 seconds, in 5 seconds, in 1 minute, which is the same as 60 seconds? All right, so we've got 11 feet per 1 second. We want to know how far he goes in 3 seconds. So times by 3. And we get 11, oh, not 11, 11 times 3 is 33 feet. All right, I want you to pause the video and do 5 seconds and 60 seconds. Set it up the same way. All right, so in your notebook, it should look like this, 11 feet per 1 second, and we want to know 5 seconds. So times 5, so 55 feet in 5 seconds. And then the last one, we do the same thing, 11 feet. We always start out with his rate, his unit rate per 1 second. And we want to know 60 seconds. How far will he go? How many feet? So times 60. And he goes 660 feet. And remember, this is a calculator unit, so you can be using calculator with these. If you don't have one with you at your Chromebook, pause the video and go grab one. Okay, letter B. Write an expression, which is, kind of a fancy way to say equation, that represents how far Hammy will run in X seconds. Well, for all three of these, what we were doing is we were taking the 11 feet that he can run in 1 second and multiplying it times however many seconds. So really the equation is just 11 times X. Remember, when you have a letter and a number next to each other, it means multiply. All right, letter C. The racetrack at the fair is 150 feet long. We are not doing the diagram, but it says write an equation to represent this situation. So we're going to use this 11 times X, so 11X, and then it has to equal 150. And then it says, about how long will it take Hammy to finish the race? So you're going to do this, and the opposite of multiplying by 11 is dividing by 11. These cancel out. You have X, and then on your calculator, I want you to do 150 divided by 11. And that is 13.63. But, and then it keeps repeating, but it says about how long. So I would just say between 13 and 14 seconds. Because this gets tricky, because it's not 13 seconds and 63 seconds. I mean, you'd have to convert that, and we are not going to do that. That would be silly. All right, AJ and her sister are entering a 200-mile bike race on their bicycle built for two. On a training day, they traveled 60 miles in 2.5 hours. They want to use this information to find out how long it will take them to finish the bike race. We don't need to draw a diagram, but we are going to do letter A and letter B. All right, so what is their bicycling rate? So that would be like, that's the 60 miles in 2.5 hours, okay? So we don't really have to rate anything for that. But now it says, what is their unit rate per hour? I'm going to write it down here because there's not enough room. So we know that they go 60 miles in 2.5 hours. We want to know how long it takes them to go, or how far they go in 1 hour. So use your calculator, pause the video, and come back when you have an answer. All right, so I divided by 2.5. And I got 24 miles in 1 hour. All right, letter B. How far can they go in 3 hours and in 6 hours? All right, so we're going to use the 24 miles an hour to see how far they go in 3 hours. Same thing, but now in 6 hours. Pause the video, use your calculator, and find out how many miles they travel. All right, this one will be times 3. and they went 72 miles. This one is times 6, and they went 144 miles. Whoops, that was one too many humps on that M. All right, good. Okay, letter C. If they bike 10 miles, how long will it take them? Explain how the distance and rate helps you find the time. All right, so for letter C, I want to use the 24 miles per hour, but I want to break it down to minutes. So instead of saying in hours, we're going to say in 60 minutes. And then we need to figure out how many minutes it takes them to go 10 miles. All right, so now we have to figure out how do we make that 24 become a 10. And if you're not sure how many 10s go into 24, because you got to do it backwards, on your calculator, you can do 24 divided by 10, which is 2.4. So that is what you're dividing by, 2.4. So put that into your calculator and see how many minutes that is. And that would be 25 minutes. Letter D. If they bike 10 miles, how long will it take them? Or, sorry, I'm reading letter C. If they bike at the same rate for the entire race, how long will it take them to finish the 200-mile race? All right, so 10 miles in 25 minutes. I'm taking that from up here, the work we just did. And we want to know how long it's going to take them to go 250 miles. All right, well, how many 10s are in 250? 25. So do that on your calculator quick and see how many minutes it takes to finish the race. And I got 625 minutes. And you could leave it like that, but if there's 60 minutes in an hour, that would be 10 hours and 25 minutes. And then we are not doing that part. All right, we're just going to go through the math notes real quick because it's got some good information. So distance, which they're going to call letter D, equals the product of rate, or the speed, which they're going to use an R for that, and time, which they're going to use a T for that. So product is multiply. So distance equals rate times time. The units of distance, such as feet or miles, and the units of time, such as seconds or hours, are used to rate the units of rate, like feet per second or miles per hour. The equation can also be written in equivalent forms of rate equals distance over time and time equals distance over rate. All right, so it is homework time. You're going to, starting on page 461, you're going to do problems 18 through 22. So you need to do all of those. And if there's time left over, you are going to do your second activity, which the sub will have for you. All right, have a good day, and I will see you on Tuesday.